Hey guys, this will be video 5 for the how to design build a custom guitar basically, and it's based on the 1956 Gibson Goldtop, the Les Paul, but it's an Explorer 58 Explorer replica, no logos or any of that jazz, and based on the Electric Herald drawings as well. And then I utilized the Stuart McDonald templates to help kind of keep me on point, although I don't really need them anymore. But they are really incredible. And the Stuart McDonald templates I'm using are based on Dan Erlewine's 1959 Gibson Les Paul. Where is that? Oh no, I'm using it as a coffee table over here. It's got a whole bunch of crap on it. So anyway, I've covered those in the past videos, and I will actually introduce this in a little while. So that is one of the Stuart McDonald templates from that set. So with that said, this is going to be a pretty intense video because I'm going to be doing a lot of pausing, and I'm going to be doing an enormous amount of work, and I'm hoping that by the time this video ends, this headstock will be shaped and profiled, the neck will be tapered, and there's a possibility if I have time, it'll actually be profiled, meaning rounded over on both sides. So this is where there's a ton of work that takes place, and the only way I'll be able to do it within a 1-hour video is because I'll be able to pause for 15 or 20 minutes at a time, because this is probably about 3 to 4 hours worth of work. So by the time this video is over, I'm going to feel like I've been standing here talking for 3 to 4 hours. So, and if I'd elect to not do anything, it would only be the profiling, the round over. But I'm definitely going to talk about those things throughout this video, because red versus blue this is 1958 and before, and this would be roughly late 50s, 59, 60, and even up to the moderns. So we'll talk about the radius and whatnot. This is a 7/8 inch radius. This is a 1-inch radius, for those of you guys that already know how to use a router bit. So in the last video, I had just a hollow shell of a lower, no truss rod in there. And the only thing I didn't talk about, which is really important and really, well, I talked about a ton of stuff. You can't remember everything. But one thing I didn't clarify, I made a statement, hey, you can install this truss rod one of two different ways. You can either install it flush with the top, but I didn't go on to clarify that when I build my necks, I always route down about another, almost a 1/16 of an inch. But I didn't clarify that reasoning is to drop the truss rod down so that I can then epoxy a fillet atop it. And then now, once I get ready to tight bond glue my fretboard down, I have 100% glue connection here and here. And I discussed it from a standpoint, if you knew what I was talking about, you would have understood my reasoning, but I didn't clarify for those of you guys who have never seen the inside of a neck how important I think it is just to have that little bit of material right there. When I say material, actual mahogany, and then epoxied in so that you're gluing down to a solid surface rather than gluing down to the top of a plastic truss rod cover. So let me try to keep myself on point and not get overwhelmed with how much it is that I'm wanting to present in just this one video. But and I almost forgot. So when you're doing let me just get these bits up here, because that will force me to talk about the bits and the operations and not lose myself. Okay, depth. The target is what is the minimum depth we can get away with when we're building the neck. Well, back here in the body of the truss rod, if we were going to build a super thin neck, well, then that was the rod we would want to use. But you might want to skip doing this fillet work on the top and just bring that truss rod all the way up to the top and be flush. If that's the case, then I think you're going to be going down probably around 3/8 of an inch. It's going to be insane how thin. But with this one, once you get out here on the end, you will, because it has all of the adjustment nut on the end, that will be your minimum uh, depth that you'll be able to cut back there. So with that said, that'll be, if you were to do a cross-section drawing, then you're going to be plowing into that right there, just on the very bottom, the point. So you'd want to make certain that you didn't get too thin. But where I'm going this, in case I forget, the original manufacturer of this design, they were nowhere near close to that. They were considerably further down, especially out here in the middle with the single adjustable truss rod. But see, that being the lowest point, you have to step down in order to receive the deepest part of the truss rod. Once you get back to this line right here, that's why there is a mark on there, because I'm working on against the router fence, and that's my stop point. That's when I know that I can stop and then step up to the 1/4 inch bit that is radiused on the bottom, that will then finish out the route. And I'm explaining this in reverse because the operations are, that was the last route you make after you've done the channel. However, once you get back to here, just in order to receive the truss rod, it's 1/16 of an inch less, because I remember the step. And the question is, where is the actual bottom of the truss rod channel in relation to Ed's neck? And I'm about to show you. It's hard to do. It stops right there. Okay. I have no idea when you'll be able to see the pencil. I think when I turn it on an angle like this, that really helps. There it is. Kind of disappears once you get to a certain point. But I'll just put this up here so that you see, well, that's exactly what I just used to draw it. So once you get to this point right here, it does step down about 1/16 of an inch in order to receive the additional material out there. However, the reason I'm spending so much time with this, there is an enormous amount of wood left in the center of my design, and that's under that fillet. If you were doing a super thin neck, then raise that up about 1/16 of an inch, or roughly a millimeter. Okay, so with that said, that shows you just how much wood is left in the very center of the neck back here. And what I didn't get to talk about, the reason I don't like the single adjustable truss rod, is because this is the typical breakage I see when somebody gives me a call wanting to have a neck replaced. There's just almost no material left in the bottom, and also the bottom of that channel is square, whereas when I do mine, the bottom of the channel is radiused, and I'm going to talk about that here just in a moment. But nonetheless, there's just nothing left, and I'm not saying just this one company. Pick all of your big boys that were doing the arch top guitars with a single type rod in the middle and all that jazz that had to be bowed. You might sit there and look at a neck that it looks visually really solid, but even they had to epoxy in, or at least glue in, a fillet atop that to try to glue the neck back together, where they literally had cut the neck in half once they cut for the truss rod. Well, there you can see it. Then it has the dowel down there. And I'm gonna stop because I don't want anyone thinking I'm throwing this company under the bus. And I joke with a lot of guys about, hey, we're copying them, and meaning like Gretsch, Fender, Gibson, BC Rich, whomever, pick your poison, Kramer. A ton of guys were copying Kramer and ESP back in the 80s, and who else? There's just a ton of them out there. So we're all copying them. They're not copying us. So they were working with what they had. But once you got to the point to where you had the more modern designs, I don't understand why anyone would still be using that design. Okay. So, with that said, as I always say, what are the operations of doing this? And I'm going to very quickly go through this so that if you've got a solid board that you're getting ready to run across your tabletop router deck, you're going to be working on the left side of the fence because the router will be up under the table, and all you guys know that if you're looking at it from the top, it will be turning counterclockwise. Well, as soon as you make contact with that router bit, you want it to pull up against your fence. So everything will be centered. If this is 2 1/4 inch width right here, then you're going to be working roughly 1 1/8 of an inch off the center, of your fence. And how I go about guaranteeing that all my operations are precise and centered regardless of what bit I step up to. I always start out with this 1/8 inch bit, and I put it in my table, and I've already got tick marks on my table. I can pretty much hit it really close to spot on, but sometimes I'm working with a board that's 2 3/16 of an inch wide. So now I'm working with now I need to locate a different center. If this material is not over here and it's a 32nd of an inch more narrow, well, then I've got to locate this center. And I do that by starting out with this 1/8 inch bit, setting it up a little bit high, but don't go up too high because you might bump into your material. But you're wanting to kiss in this location right here to locate the center, and then you just push up against until you see a little bit of dust, and then stop, and then flip it over this way and look at where is the cut. You want to look at where is the cut, and if the cut is over here on the right, well, then you need to move your neck over to the right, or you need to move the fence over. So in other words, don't do this work and then turn it around like this and start assessing it. You'll start getting confused on the direction. If you do the right work like this, pull it off the table and flip it over and look down it, you'll immediately see where the route is. And once you start kissing back in this location till you get back, so you could work yourself crazy eventually finding that center, as long as you don't go too deep or too deep out here or too far back. Well, you could actually go pretty far back, but nonetheless, you should have found it within about 3 shots. And then once you find that center, lock your fence down, make certain it does not move. Now you're through with this bit, and you're ready to transition over to your 1/4 inch bit and start cutting the actual channel. And then I usually cut about three different passes to get the squareness, get the channel squareness. Now let me back up. I do go ahead and take this 1/8 inch width router bit right here, and I do go ahead and take a pass all the way down the neck, just to verify nothing really weird is going on. That maybe this part of the board was the very edge of the rough material that I was working from, and it's not very true, or maybe this one's not very true. Well, let me back up. This one better be true, because this is the one that you're going to be working off of. It doesn't matter what's going on over here, because once you get that truss channel in there, both sides of these boards are going to be machined off. They're going to be tapered, and you guys already know that. So you're only keeping S4S as long as necessary, and I definitely need S4S because I'm getting ready to cut this tenon. And then once you've got that tenon cut, and then obviously this truss rod cut in there, you're ready to start tapering. So I didn't mean to digress there, but once you've got it guaranteed center, then I route with the 1/4 inch bit, a couple passes, get some depth out of it. Then at that point, and I kept forgetting in all the past videos, I talked about the truss rod being round on the bottom, and it is an actual 1/4 inch truss rod, and it is round on the bottom, but it has, the wrap around it. But I go ahead and take a 1/4 inch round nose bit, which would be a 1/8 inch radius, but it's just called a round nose. Then I make my couple more passes all the way to the very bottom. Therefore, my truss rod goes in and cradles into a channel that is perfectly radiused on the bottom. And then since the truss rod is dropping below the surface, once I glue in this S4S fillet, and this fillet is sticking up about 1/8 of an inch, 3/16 of an inch, and it gets machined off level with the top the next day after it dries. But you see my reasoning behind it. Takes me 2 days just to get the truss rod in, laid out, and designed after I've built the neck lower in the S4S fashion, and I have something to work with. And that's what I was clarifying in the last video of why I charge what I charge to build a neck lower, because it's not like a 3-hour job. No one's complaining. I'm just I have a lot of guys that are asking me, "Hey, what would you charge to build a lower?" And I know a lot of guys out there probably think it's a $300 or $400 operation. It's not. I mean, you'd end up making $2 an hour for your time. Plus, you've got to provide choice master level Honduran mahogany that's quarter sewn and on and on and on. Okay, so again, not complaining. Just that's why I do these videos, to show you guys just how much it really takes to go into this. And what is this right here? This is the life of the guitar. And from day one, after having roughed this out of a rough board, it's never moved. It's just amazing. This is the first time I've ever seen that happen. As I clarified in the past videos, typically they want to pull down. They want to pull down just a little bit, about a 32nd of an inch, but this one did not drop down. So that's pretty incredible right there, how stable the board is. Okay, so with that said, now we're off to the races, and we're ready to start fitting the truss rod in right at the point where we realize, oh man, our 1/4 inch round nose bit just wasn't large enough, because the top of the truss rod has all of that additional material to make it function. So that's where you've still got your fence in location, and now all you got to do is do a very shortcut up to about this point right here with your 3/8 inch round nose, which would be a 3/16 inch radius bit. And what does it produce? It produces a headstock that I've never seen before. And I'm not going to say this is my own particular design, but I've never seen anybody do this. And why do I do it? And it's really beautiful, because truth be known, you can even just leave it like this and finish it. And because if you're truly a touring guitar player, or a player that's going from climate to climate, you always kind of want to have access to your truss rod just to be able to kiss on it a little bit, maybe encourage it to move forward or move back and whatnot. So a lot of times I'll just leave the well, I say a lot of times, every one of my guitars upstairs, they don't even have the truss cover on them, because I'm always tweaking them a little bit. Okay. But anyway, the reason I do this fillet work right here is I do want it to be as structurally sound as possible. But what it really boils down to is there is a center line right here and a center line right there, which you can identify the location of your truss rod cover, and therefore it gives you somewhere for a a screw to go through a substantial amount of solid wood back here, and there's not an issue out here because you have solid wood out here. But also, it just guarantees that you don't run this risk right here of machining too deep. Now, the 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 deeper the pit, the more pitch you have in the headstock, the shorter this run's going to be. But if you had a really, really shallow pitch of like 12 degrees or 10 degrees, you got to be real careful about this because you'll have a tendency, um, it'll because it's higher up out there. This point right here will end up being about right here, and it's amazing what 1 or 2 degrees of less pitch will cause that baby to really travel further out because this depth. Man, this is way too much information, but it just lets me know how much is really going on behind the engineering of a neck. But this depth can't change. And as that pitch decreases, well, then it just causes more material to be removed right there, therefore requiring your truss rod cover to possibly shift forward a little bit if you weren't careful. But fortunately, with all the guitars I build, they don't. The screw hole for the front usually lands right there in the little at the beginning, and then it covers really well. Okay, way too much information, but some incredibly valuable information. So with that said, I'm going to keep going with the video and get myself back on point. However, get this crap off the table, and that way it'll be out of sight, out of mind, and I won't keep talking about it. Okay, and I kind of regret talking about the truss rod first. I wish I had have talked about the tenon first, but if anything, this is kind of cool because now we don't ever have to talk about the truss rod again. So obviously we still have this rectangular classical looking guitar going on here, but it was time to prepare for cutting the tenon and then getting ready to fit it into the body. So what had to be done, the next move was it was time to set up my table saw and also verify that my table saw was in fact true, and it was still true. However, let's say this is your table saw fence, and you're getting ready. See, I'm trying to do these videos where I'm showing you guys how you can just use basic hand tools and shop tools to build these things. But obviously you're going to be taking some material off the back here, and in case I forget, this is about 1/16 of an inch deeper than the body is thick right now, so it would allow us to do a flush back to heel configuration per true 1958. Well, there's a little bit different, but it is flush. So we could do that, or if you want, Ed, then we could step the heel down where whatever material is in the body out here will step the heel down about 3/16 of an inch, and it's a really beautiful heel, but it wouldn't be accurate per 1958 specs, and we'll get to that stuff later on. However, I had already defined these two side cuts, the pitch, which is 2.5 degrees, but I had not cut this top point. In other words, I had not cut down for the tenon because the tenon has to offset. But I knew I had to get all of this mass out of the way right here. So this was a perfect opportunity to verify my table saw was true, because I'm about to use my table saw in order to cut cut the tenon. So for you guys that truly want to know how to build a neck, stick around. Even if this is an 1.5 hour long video, I'm going to answer every bit of those questions, because now that I've got my table saw true, I have verified the blade. The blade is all the way as high as it'll go. I think it might be a 3 1/8 inch, give or take, height. I'm going to be cutting that side right there on the outside of the line. There's a possibility, because I trust my table saw and I trust my layout, that I will just be flipping this over and then cutting the other side. Because if I'm truly working off of center and everything is true, once I achieve that table saw cut there on the outside of that pencil mark, hopefully that'll show right there. Once I flip it over, I'll be on the outside of this pencil mark. And what will that define? A 1 1/2 inch tenon, but a tenon that's on center. And that wouldn't work in a vintage guitar because actually they're offset. So that's a different animal altogether. However, if someone said, hey, I need a vintage tenon, but I need it to be offset, then I would just have to engineer that and cut it accordingly. I'd still probably use the table saw. Probably my ass. I've been using that forever. It works great. So let's do just that. So once we had our table saw blade up here sticking up really high, we're gonna cut this off. There's no sense in pushing all the way through because you got crap going on down here. Just push up, make the cut, and then pull straight back out, obviously. And then you want to really guarantee that your table saw truly is true. And you ask yourself, well, that's about as true gets. And if it's true there, that's S2S. It's really square one side. I don't know if that would be considered S2S, but sure is cool that we're at least now S square on three sides, 1, 2, and 3, even though it's 2 squares. But then you could just keep carrying that around the whole neck. And what I'm saying is, regardless of whether you're machining on, this side of the fence or on this side of the fence, or you're flipping the neck over here or over here, you're working with an S4S, square 4 sides billet, and then it ought to be a walk in the park. It really should be a walk in the park. So let's do just that. Let me pause. I'm going to go over to the table saw, and I'm going to do a little bit of trickery. And the way you can guarantee that you don't cut up into your neck and screw anything up is you raise the blade as high as you can get it. This is really important. Okay. So let's say that's the blade. That's the blade right there, and that's the table saw fence. Come in here with a square, and then kiss up against the blade where the tallest point of the blade. Find that dimension, and then back up about 1/8 of an inch, and take a black Sharpie and draw a line out, and then do the same thing on the other side. On the other side, I wouldn't ever show you how to do it, but a lot of times I'm cutting from the back side. I'm pushing into a pulling cut, which as long as you're holding on to your material, you'll be okay. But if you're not holding on to it, the saw will grab it and pull it away from you. But I want to know where those stop points are, on my table saw. So if my blade is all the way up, I want to reach up there and then find that point, move out about 1/8 of an inch, make a black Sharpie mark, so that once I'm doing my table saw work, I can't see the blade. I can see the blade up here, coming through, but I can't see where the blade. I can't see the blade once it's reaching to this point right here. And when I say I get dangerously close, I get within about 1/16 of an inch up here. When it comes to down here, that might be a different story. Because why? Because that's the guitar. You're going to see that. And if you screw up and you run up into that any amount at all, you're going to show how good you are at making things go away. And I am. I'm pretty incredible about making repairs and doing little epoxy fillets and stuff like that. As long as you stay on the grain, you'll be fine. But we don't want to make repairs. We want to stop when it's time to stop. Hence the reason I did this initial. This is not the saw I use. I use my fret saw for this, but obviously I've got a certain depth right there based on the tenon on both sides, and then I've got a certain depth right here. And see, the cool thing about that depth, that actually pitches. That's a 2.5 degree pitch. And all this has to be done by hand. And Edward, I took some pictures of this just on the table, and I'll send you those attached pictures as just like documented build pics. But nonetheless, you're doing all this little real gentle handwork so that you can now go over to your table saw and start taking off the mass. because that would be a nightmare. One way to do it is, I don't want to start talking about it, but one way to do it would be on an overhead router, where you, if you trust your router table, which I don't trust my overhead routing station. It's not perfectly true, so it would not guarantee that I got a real nice flat. But if you had a perfectly flat surface in an overhead router, you can come in here and take material off like this until you get down to that pencil line. Or obviously you could set a router up there and route it off. But I don't like that because you don't have a surface. Okay, so let me stop bringing up hypotheticals because this is going to turn into a way too long video. Yeah, man, I'm already at 30 minutes, but I'm not going to stop because, again, as I said, this is some incredibly valuable information for those of you guys out there that are truly qualified to use the miter saw, the router, the table saw, the jigsaw, paintbrush, whatever you're qualified. Know your limitations, and if you don't think that you're going to guess on this stuff and get lucky the first time. It ain't going to happen. You're going to have to locate someone that you trust and pay them for their time, even if it's your dad or your grandpa. Make certain that you compensate them for helping you out. And I got a washcloth back here. Let's see what this thing looks like a little bit before we. This is the first time I've done this. Is there any figure? There is. There's a little bit of flame. Very cool. So there's Honduran mahogany. Really beautiful. Okay, and we'll talk about this headstock stuff later on, but nonetheless, I want to go over there and do some tenon cut work and try to get my back on point so this doesn't turn into a 3-hour video. Although if I were able to do that, it would be an incredible video. So let me go do some relief work, and then I'll make it turn into a tenon. Let me think. What else should I do? Okay, all right, be right back. Hey guys, I spent a couple of minutes there doing some kiss cutting. The first cut I made was that cut, and the second cut I made was that. And how did I do that? Obviously, on my fence. Let's say this is the fence. Got the table saw set up for the outside of that mark, and just did a kiss cut there. Verified that I was staying true, and then once I felt like, and I literally just touched it the first time, and then flipped it over, and then touched it to see how consistent they were. And based on the pencil line drawing here for this tenon, I'm showing about a 64th of an inch more material than I would like to see. But I think that's going to be a safer cut because there's a possibility I have this tenon drawn, not, CNC type approved perfect. But as long as I get within a 64th of an inch, I should be fine. So I'm going to pause and go ahead and make the final cut. And then after I do that, I'll fire up the camera again, and then we'll just keep doing it until we get a tenon in front of us. Okay, I made that cut, and I went ahead and did some assessment, and it's too wide, which is better than it being too narrow. But if it were too narrow, then you could use one of these drops as a shim in order to, tighten back up. But we don't want to do that type of work if we can. So all I did was just mic'd it here, could care less what that number is, and then go to our body, which it's very, very important that once you machine your body, I say that, you make sure it's clean. Feels good, looks good. Just a little bit of epoxy right there. Might need to clean that up a little bit. I should have cleaned that before I started the video. But then what you do is once you lock that down, you take that assessment right there, lock it down. Now just come over to your your mortise, and see, will it drop down into the mortise? Or you can also look at it and I'm looking at a almost not quite a 16th of an inch. So roughly, I'm going to say at this point, how do I start working this in? See, the tenon, the mortise location is already true to center line based on my templates, based on the center line of my maple, which is based on the center line of my body, which is the guitar. So what am I saying? Don't touch that. Leave that alone. Unless there's some epoxy bleed over, make sure you clean it up. Do your fit work here with this neck. However, don't deviate from the center line of this truss channel. Okay, so what I'm going to do now, I'm going to go over there and I'm going to tighten up my if that's my blade right there, what I'm going to do, I'm going to move my fence in just enough. And the cool thing about, the reason I love that contractor saw, even though it's just a nice little DeWalt contractor saw, you can loosen up the fence and you have a dial crank, and I can feel it. I can just feel it jump just ever so microscopically. And I can literally just ease my way to the finish line. And that's exactly what I'm about to do. And one way to gauge if you're taking any material off, come in here, make some witness marks, I think they call them. Probably won't be able to see that one because, and I don't want to be sloppy and just start trying to break this off or crap like that. Take your time and work your way to the finish line. This is why I mentioned it's so important to have those black Sharpie marks on the table saw deck that tells you exactly when you're getting close. Okay, so let me pause. I'll be right back. Okay, I made 2 more microscopic cuts and I'm almost there. And what I did, rather than measure the tenon and then try to then measure the pocket, what I did was I just, put my calipers up in here. I'll try to get this on camera. Just put my calipers in here and then locked that down. Now that I've locked that down, what does that tell me? Well, that's my real target. So, and that's actually a little bit tight. Probably just because of the way I put it in. Again, I'd rather take an extra 30 minutes and get this thing as true to perfection as possible. And if it won't reach right there, it's really close. Probably could force it in, but that's not necessary. Okay, so let me make 2 more microscopic cuts, and then I think it will be then time to fillet these sides off. And one thing you can do, because once this is on the floor or on the side table, you'll never know other than by seeing the saw marks, you could identify it. But I always draw a circle, an arrow, and I put base, we'll go 58 GTX. So that's your guitar, Ed, the 58 GTX for Goldtop Explorer. That's treble 58. All I'll be able to do is G over there. So in the event I slipped and really screwed up, then I know that I've got a piece down there that grew in the wild so close to that it'll vanish when I make my repair. And have I ever had to do that before? More than once, but not recently. All right, let me pause. Okay, I think we've got it. Based on that, when I say it's loose, it's just move. I can just feel movement, and that's what I want, because when I epoxy this in, I don't want to be, trying to force anything in. So she's ready for me to fillet these sides off. And let me just do that, and then I'll come back and talk about how I did that. Okay, I would say that I haven't checked it, and we'll check it in real time, but I did check it, and it's about as close to perfect as you can get, and I haven't even done any chisel work yet. So let me just get something under there. Pretty cool. I have not done this yet, so if it falls out, I'm not certain I'll continue with the video, but maybe not. If it's going to fall out, it would fall out right now, so let me just cradle it. That's what you're shooting for. With a contractor grade table saw and a couple of hand tools. It's not me, it's just everything's lined up. Well, I mean, I know what I'm doing, but anyone can do this. And it's really beautiful. So as far as the center line, you just look down it. I'm looking, see there's a center line glue up right there. I'm just getting it as far away from my person as possible and looking down the pencil line I got drawn on the neck, and it looks perfect. Now, looks are deceiving, or can be, but it should be close enough for rockabilly, as I say. All right, so how did I do that? All right, you see what was left over from the table saw marks, and it's amazing how quickly you forget. I mean, immediately I would have forgot. Well, other than that snipped on the corner there. So we know that cut was right there, and we had that material to relieve off right there. And then this cut is over here, obviously, and the same amount that we had to relieve off, but not nearly as much of a flat surface. But carpenter's vise, with it set up vertically like this, so you can, the most important thing you want to monitor is not getting into the heel and not getting into the heel. Those are the two most important things to monitor. The third most important thing is to not get into the deck. But if you got into the deck a little bit, that's not nearly as tragic as getting into the heel, especially if it's like a bird's eye maple jazz neck 5-piece that it took you 2 months to build, and then all of a sudden those are hard to conceal. But the carpenter's vise, very nice and flush, and go up under that piece. And this is just a very affordable, but it's a very aggressive saw. This is a flush cut hand saw for doing hardcore heavy duty handwork, and I use this for pruning trees. There's a small maple tree that I cut down with this. It was hilarious because it worked so well. But this thing is tough as nails, and if you lay it down on that little bit of flat that I had right there, and in the carpenter's vise, I'm not having to hold the neck, but all I'm doing is reaching down, and I'm just, obviously don't get in front of it, but I'm just verifying that it's staying flush right there, and I'm just doing a real gentle cut. See, like right now, I could sit here and kind of clean that up a little bit, but as long as you let gravity work to your advantage, it'll cut almost perfectly flush right there on both sides. And again, I haven't even chiseled this. I haven't had to rasp it. This is what this is. I don't know where this is the rasp. Woodcraft. This one's radiused on one side, flat on the other. The taper, I could build a whole guitar with this one. I had one that was just straight, but I got heavy-handed and broke it in half, so I just epoxied it to a top of mahogany. This would be the final pass, P-A-S-S right here. Let it sit on the clean table saw cut, and then just do a little bit of scratch rasping. and then you know that anything that might still be there is now gone. So again, every bit of this done with a table saw and a $20 hand saw. That's pretty cool. And how did I learn that? From an old violin builder guitar book. The guy was showing how you could use a contractor saw to book match curly maple. It was amazing. The guy was, he's taking a handsaw like that and sawing large pieces of maple in half, and he was book matching them with a contractor grade saw, and then carving everything. So that's how they did it back in the day. And apparently, I got something on there because I took some acetone and cleaned that off a little bit. But we've got a tenon, but now it's time to define the bottom. And here's the only thing that will happen in the guitar that will change the body. See, I still haven't pitched this yet, nor have I found the final depth. So what I'll do now is I'll clean. I'm about to define the height of the tenon on the table saw again, and I'm going to repeat the exact same process. I'm about to pause and do this. And then once I define the height of the tenon, very unlikely that I'll ever be, well, that's not true. I'll probably take it down to, let's just say it's 1 1/8, and then at the very end of the job, I might set it back up on the table saw and kind of encourage a little bit more dust to come off of it by dropping it down. But I will not be doing any taper of any sort up here. The taper will be in the body, in the bottom of the body, and the taper will be matching, the tapering will be matching that right there. It's 2.5 degrees. Okay, so I'm trying to do too much in one video, but I think as long as I can just stay on point, it might seem kind of chaotic as I'm doing it, but should be a good video. All right, let me go define that. Let me go define that bottom, and then we'll see if we can fit a little bit tighter, and then I'll crank up the oscillating table sander, and we'll start radiusing this tenon. Okay, started relieving that bottom. Same principle. What I did, I relied on the deck right up to this point, but then just to make certain that I didn't get confused, because there was nothing to look at down here. If you're not careful, if you start looking at the wrong point, you might mistakenly plow up into this. But what I did right there at the last, I just went ahead and tipped it up, and then I literally just watched my black Sharpie marker on the edge, and I stopped short. There's no sense in trying to show how good you are with the table saw, because you're going to be coming up in here with your pull saw or your flush cut contractor saw. I could have stopped back here as long as I could guarantee that I stayed on that surface. But the more machined flat that I create, the more I'm guaranteed that I got a perfectly S4S tenon, and everything was done by hand. So I got to cut out this material over here. And if you didn't trust yourself and you were working with crappy tools and stuff, come in here and define that point and make a pencil mark across that top right there. And then let's do that just to be safe. Sorry about that. That was probably kind of loud. That will give you a reference point. So like in a little while, once this comes out, if you start having some sort of fitment problems and you start rasping the crap out of it, and you realize that you've gone beyond your pencil line, well, then there's probably there's something going on in the body that you need to be addressing. So I'm going to go fillet that off, and then we'll go from there. Okay, I've spent a few minutes just doing a little bit of a cleanup and shaping, but again, the same principle, where you're just cleaning off some of the marks. Just keep keep an eye on these corners, because if you're over here filing and sanding, you won't realize that you're actually cutting into something over here if you get distracted, or if you get overwhelmed and you get overly emotional. You'll be messing something up. And if I've ever gotten hurt, it's always right here, like where I'm taking a chisel and trying to do something, and I slip and come off and go into my hand because I'm holding it, thinking, oh, it's just a little piece of lumber right there, or just a little small piece. But I've gotten to where I do a lot of this stuff while it's still in the carpenter's clamp to just verify that it's clean. But that's usually where I get hurt, right there, or cleaning up epoxy where I glued it in and I'm trying to like shave that off or some crap. So just be careful. Okay, probably the most important thing, well, after checking to see if it fits, which I haven't checked it yet. Yeah, beautiful. Okay, so the most important thing, let's put that back in the background for added drama. All right, so this was your original base that you took off. Here's the bottom. This is the very bottom, so that would go right there. And then this would be the treble side, which would go right there. And this is the base side. So that's all your machine work right there. Everything that you did came from that location. And the reason I'm showing this little piece right here is because what I always do at this point, every guitar I build, I'll tape these together, and in the event I had some sort of damage, or let's say I'm building another guitar out of some of the remnant material and I might want to do some visual trickery, then I know I've got these pieces that I could actually glue together and make things disappear or appear. Okay. And once you have everything identified, it's out of sight, out of mind. We'll call it master level tenon work. It's pretty darn good, and it's really beautiful. It's a little bit. I kind of intentionally made it, that final table saw cut, I made it just a little bit more loose, just so that I don't know, it's holding okay, so that it would be easy to fit it in and out as I'm doing the video. But yeah, see how it fell right there? But you know, once you get this is definitely an incredible candidate to be a tight bond glued in, because that's a phenomenal fit right there. So let me pause and let's see if we can do this right here. I don't think there's anything to see right there. And another thing, I think the way you test it, well, I won't be able to do this until I get the heel length cut. So let me pause for about 5 or 10 minutes while I go fit the length of this tenon. And then hopefully I'll be able to possibly end the video with a really beautiful fitment, you know, all the way up to it, if we're fortunate. But if not, at least I'll be closer to the finish line. I'm sorry, let me power back up. I forgot something right here. This is, if you ever make a mistake, this is where you'll get in trouble. Make a measurement. And verify you're not fooling yourself. So that's your target on the bottom. Okay. And where this will get you in major trouble is in a Les Paul replica, because they have such an extreme pitch. It's like 4.30 degrees. It's a real extreme pitch. A big body jazz guitars is like a 4.5 degree pitch, a real steep pitch. And I'll just exaggerate, if you take a measurement from one location, like for instance up at the top, if you took a top measurement and then you taper that bottom and you start taking measurements again, but then you come over here and you transfer those dimensions maybe up to the top, or maybe onto the bottom. I'm not going to try to define which one it is. And you make a straight cut, you'll end up being like 1/8 of an inch too short. And you're thinking, how in the, what did you get there? Well, the measurement that I just took, excuse me, was the bottom of the mortise, right? So when I come over here and I start chopping off the length of this, I want to be working from the bottom of the tenon. So whatever measurement I took was in a certain relationship of that pitch right there. If I took, that's where I usually make a mistake. If I took this measurement from up here, then I'm too short, because the pitch back distance, you see my point? Or either I end up being too short because I measured from one of the wrong lefts, and got me in trouble. But just know that whatever it is you're measuring, like if you're measuring, I'm not even going to give a hypothetical. If you're measuring up the top, then make certain that you measure at the top, because then you'll have to transfer it to the bottom and accommodate for the offset. I'm just talking about how the pitch will throw you off. Okay, sorry to get so long-winded, but that'll really make you sick when you've spent all this time to make a really precise master level fitment up here, only to take the measurement from the wrong side and you end up almost 1/8 of an inch too short. So let's see if I can make certain I don't make that mistake. Okay, at this point, one thing you can do, I just did a chop. I left it about a 1/16 of an inch longer than I really need to, but a lot of times you can just come in with little things like this and make an actual fitment and then start verifying things like that. Now you've got something to just work from, and you're not worrying about a template to work with, and you're not worrying too much about calculations, dimensions, and stuff like that. However, what's about to happen, I just realized I haven't pitched this yet. So let me pause and see if I've got time to go ahead and pitch this. I say that, I mean, I might as well. So it's not like, that's what I meant by at the beginning of this video. It's going to feel like I've been talking for 3 hours and I'm going to be compelled to try to end the video. But let me just reel myself in, press pause, go pitch the bottom of this baby, and then let's build a guitar here. But otherwise, rather than starting to do any radius work yet, I don't want to get ahead of myself. But I don't know if I've shown, well, I couldn't have shown it because I had not chopped it yet. But you can just begin to see that the guitar is obviously coming together and staying true. I didn't expect it not to. Once you define that tenon, let me make sure I don't knock it off the table. Once you define that tenon, I'm just talking about center line. Once you define the center line of the tenon versus the mortise, and you've got this pitch under control on the side, it's a kind of a, it just, I'm not going to say it's easy, but it just eventually materializes. So let me pause, pitch the bottom, then we'll be able to start fitting this and maybe have a guitar together here fairly soon. Okay, I've been paused about 35 minutes, if not longer, because I decided rather than just jumping to a really nice fitting tenon, that I would just go ahead and share this with you, how I would go about just using poplar to build a little jig, a tapering jig. And if you're doing a flat top guitar, and the whole idea is we want something that will keep our router stable as we've got our body fixed and not moving. However, and I'll talk about this some more in just a minute, so let me put that to the side for right now. But the objective of your flat top guitar, and this is going to be the most important statement in the whole video series of any type of custom guitar build. If you're building a flat top guitar like this, typically, not always, but typically, the top of your fretboard, or the bottom edge of your fretboard, is basically just barely kissing that corner right there and then however high you want your bridge will be determined upon your the pitch, how much you pitch. I'm talking about the pitch here, not necessarily the pitch back here. They should be the same. But so if I'm 2.5 degrees right here, I want to pitch the bottom 2.5 degrees as well, so that if that's the case, then I'm putting everything that is square into a pre-pitched slot. Okay, so most all of us understand this. If you're this far along in a video like this, you got a real good understanding of this. But where most people get themselves in trouble, and I'm guilty of it as well, is trying to calculate, okay, well, what is going on from this distance here to that distance there, and this pitch and that pitch, and you start getting overwhelmed in the numbers and stuff, and then you're thinking, well, okay, well, I've got to taper this, so it's going to be more shallow back here than it is out here, and then you just get lost in it. So what you just want to make certain that there's an end target here to guarantee that you don't go beyond it. And one way to do that is just simply do some real simple blocking up on the table. And if you're wanting the bottom edge of the fretboard to kiss the very top edge of the binding, once the binding comes around the corner, and not have to get tapered off, if that's what you want, then whatever this distance is from the bottom edge of this fretboard to the bottom edge here, you just want to draw a line, a stop point. So just take whatever tenon you've already created, push this down, and then make your line, like your stop line, okay? And that'll define your guitar, or at least that'll kind of give you a crutch as you're over there on your routing station and you're wound up thinking about pitch, everything, this, that, and the other. Then that'll just kind of be a defining point. And also, as you're doing this route work, see, once you're doing this route work, you might have it so clustered up that it's difficult to get to access. Yeah, I'm almost certain, because this, yeah, it will, because these will be hanging over. See, these won't be back here. These will be hanging over like this. I'm about to show that in just a second. So you won't be able to put this up in here and fit it. You might be able to, but I don't think so. But quite frankly, we want to try to get as close as we can to the finished guitar, so that if possible, we don't have to go over to the table saw and machine off any more of our tenon back there. If we can. If we have to, it's not a big deal. It's not a big deal at all. But I like the idea of attempting to do extremely precise work on the front end. That way, you're just really processing through and thinking about absolutely every move you're about to make. So your objective here with this little jig, and I really don't have time to talk about it, but just take a look at it. Basically, you could call that the tenon. That's the tenon width, or it should be. Unfortunately, it's not, because when I initially made this, I made this just a little bit loose intentionally, so that it guaranteed that just clearances and stuff regarding what bit I might end up using. I didn't want this to interfere with a very precise pocket mortise that I've already created. I want the bearing to always be making contact with this body, or said body that I'm working on. I don't want this to be the defining point, because you can see where a bearing got burned into it right there. So whatever's burned in right there will always get introduced in the next body. So what is this? It literally is just a 2.5 degree pitch. That's all it's meant to control. It can act as a stop point back here, and you might be thinking, well, how do you get it on the body and get it centered? Well, it doesn't really matter microscopically, because you can use your tenon here, okay, that we know that's our guitar, that's our mortise, and all we want to do now is make certain that if for some strange reason we have to allow the bearing of one of the bits we might use to come out of this body. At a minimum, we want to have this stop point back here. If we're looking at it from the back side, we want to make certain that if that bearing has to kiss up here, because see, I might be using an incredibly tall bit, but I can't go, I don't want to go that deep. Maybe I only want to go about that depth right there. It's like, well, crap, now I've come out of my body. Well, no reason to panic as long as I've got a round bit and a square corner and a stop point that I trust. My tenon, my sample tenon here is about to define where this is going to be placed. So, and where is it going to be placed? Very gingerly, I'm just going to push that up there and just, that's it. That's all I want it for. But is it on the center line? Well, let's look and see. Look, it was until I tipped it over. And this is, I'm going to try to pretend like, okay, I'll tell you what. Let's see if this trick camera work here. Okay, I'm about a 1/16 of an inch off of the center right there, only because that it might have moved a little bit. But all I'm saying is all you want to do is push that to center, and you can do one of two things. I designed this little jig in order to put a board across the back right here, a fairly substantial board that extends the full length of my table, and I clamp it on both sides. That clamps the body, but nonetheless, I still want to do double-sided tape on the bottom edge here. So let's do just that. Let me do a little bit of quick pencil work and show you how I use my masking tape and jet glue. Okay, so I only need to tape up to about right there on both sides. Oh shoot, that was way too much tape. Well, I'll just have to waste it. I can feel myself wanting to rush the video, but jet glue, CA glue, medium strength. I call it jet glue because I used to buy it from a guy in Hoover, Alabama that was a professional model builder, and he built like extremely high-end jets. We're talking, this was like 30 years ago. This is when, you know, you didn't have any online information, and this guy was phenomenal, like a military jet scale builder. And he had it in stock, but he called it jet glue. And it was literally like his I think it might have been his brand. You want to get as close to that center line as possible, because that will guarantee that your pitch is truly on center. And because if you got this pitch off, then it's going it will cause your route work to be cattywamped in a weird way. Okay. And if you clamp this, it'll be a little bit stronger. This is paint grade, so it won't really matter. But sometimes you obviously would not be doing this on a vintage 1958 Explorer, because sometimes that oh crap, sometimes that jet glue, the CA glue, will kind of penetrate through the tape, and screw up the finish. So as long as you don't clamp it, you should be fine. Need a little bit of pressure back here just to make certain. All right, odds are we could go into that blindfolded, whether we're using that bit right there. We'll see, we could use that bit if we're going into like a Les Paul type body, which is real thick, like 1 3/4 of an inch thick, where we're really reaching down and we're taking out some mass. But we can't do that with a shallow body, so I'm going to have to come in here with this configuration, and I had to do this plow work in order to allow the tip of the what do they call that? Oh crap, the collet, the router collet to actually recess down in there. Although the bearing, I won't be burning up into my jig, but I did need the additional depth so I could get at least some sort of bite back here, and that's the threshold. The only reason I say it's okay to run it shallow like that, I'm running it at a really low speed. If you start trying to do crap like this at high RPMs, it'll probably either break or hurt you really bad. So I wish I hadn't even shown that, quite frankly. So the objective about running a router, you always want to be up in there really well, but sometimes you got to rob the 7-Eleven. So all right, let me pause. Let me think. Should I pause or just keep talking? It's ready to. Okay, one thing I will do now is assess. That's why I made the pencil mark. That's the whole reason I did that, because I wanted to see how safe is this going to be if I let my router run all the way to the bottom. How close am I going to have to get? It's going to be really, quite frankly, that's pretty dangerous. So what I'm going to be doing, I'm going to start out really shallow, and I probably will come back at the very end, and then I don't know. I'm not going to do anything dangerous, though. I do know that. So I'm going to start out right here, do a little bit of route work, pause for about 10 or 15 minutes, get this cleaned up, and then come back and we'll fit the tenon. Okay, it's been about 20 minutes. I hope the camera doesn't cut me off, but if it does, let me just do some real quick flyby here and pause if you need to. And look at that little wormhole down there. Isn't that amazing? Sometimes that's how close you can get to just dumb luck. But should still be able to wax the back and it not show. All right, let me just throw that over the side. Wait, all right, let's do some quick assessment. Beautiful. That's a professionally built, finished body. Ready to receive some work here that I still haven't done. But what our target is right now, we're looking at this point right here. Incredible. Perfect. So it's close enough for rock and roll, but I will need to shave just about a 32nd of an inch off of that to drop it down some. Well, maybe. Because I say that to say this, in case I forget, a lot of the 50s Explorers, they were sanded a little bit. Whatever the neck pitch is, the neck was actually just about a 32nd of an inch below the top, and then they sanded that little corner there because it didn't have binding, and what that allowed for whatever pitch they were working with. See, they might have had a 3-degree pitch, and the bridge was running. Damn, where's the bridge? There's a bridge. This is so important, even if it cuts me off in 5 minutes. If they were trying to build that guitar with, say, a 3-degree pitch jig that they had set up that they didn't want to change over to a 2.5-degree, but their bridge was too high, then all they did was exactly what I just said: shave off some material here, drop this baby down into the body, and if it's below that corner, then they just sanded off that corner because what they did, they dropped the entire playing surface down into the body a little bit, but it got them in trouble on some of their guitars because if you recall, in a lot of their guitars, in the neck position, the bridge pickup, the neck pickup was below the top of the ring. So they didn't have that body, they didn't have that design refined back in the 50s. The V and the Explorer, they just weren't refined. It should have been a 2.5 degree pitch, and the top of the neck lower or the bottom of the fretboard perfectly flush with that corner. 2.5 degree would have yielded your 11/16 inch bridge height. Okay, and that's our target, 19 millimeter. So I threw you a trying to curveballs there at the end. I'm going to attempt to pause again and round that over, but man, I'll be surprised if the camera doesn't cut me off here pretty soon, even though it's not giving me any indication. But I haven't done a video this long in a very, very long time. So in the event it cuts me off, let's just do a quick flyby of a pitched neck, almost fit. We're close, very close. And I'll take a chance. I'll pause it and go do this round over work. But before I do, I think it just cut off. No, it's still clicking along. This is what I was talking about. Once you machine that pitch, this is where I also see that once this is machined on a pitch, it cuts deeper back here in the back than it is up on the top. So therefore, it allows the tenon to go in a little bit further. And on this one right here, at 2.5 degrees, it's about a 1/16 of an inch. So fortunately, I chopped this off about a 1/16 of an inch long. It'll still be perfect. You still want to have a little bit of material, a shortness back here, so that any epoxy or glue can flow out or squeeze out. But I'm attempting to do like master level fit work and radius work to positive and negative space. And that's what I'm attempting to do, is to do just really high quality fit work. So let me pause and round this over a little bit and see if we can end on a high note. Okay, just drew the pencil marks on there on the corner. I moved this up about a 1/16 of an inch. Drew the pencil marks, oscillating sander. Took a few minutes, but look how much it moved. Literally 3 minutes worth of sanding. Look how much closer it got. Very cool. So I doubt, I'll be able to finish the guitar tonight, but I'll do as much as I can before it cuts us off. I can't believe the phone hasn't cut me off yet. But I'll pause again and go back to the oscillating sander. What you're looking for now is that the pitch, that you can feel the tenon flat on the bottom, and then when you look at it visually, the gap that you're looking at is consistent. If it's tighter on the bottom versus the top, et cetera, then you got a pitch to mortise issue. But as we start working our way back to the finish line here, I think we're going to realize that it's going to end very close. I'm looking at it right now. It looks perfect. So I'll pause again, and we'll just stay up all night if we have to, and go from there. Be right back. Okay, I'll dive in quickly and try to wrap it up. It's not finished, but it's very close. And what you're looking for now is to start taking some parchment paper and find where it's tight and where it's loose. It's a little bit loose on that side. But so I'll be removing a little bit of material here and just a little bit on this side. Or at a minimum, right now you're just taking a visual and you're asking yourself, what does it look like? And it looks incredible. It's really beautiful. It's coming together really well. Try not to panic, because I know I'm worried it's going to cut me off before I say something really profound. But it's about another 30-45 minutes worth of shape work. But what's going on with that tenon will is what will reveal what will be going on in the bottom of the neck pickup location. So, and you can start hearing the guitar come together. If you want to check your work and see how true to square you are, get in the bottom of the mortise. And when you're as good squareness 180 degrees off, you know you got a true guitar coming together. Okay, all right, guys, I appreciate you dropping in. And feels like a long video for me, but it should be a really informative one. And have no idea what else to talk about, so I'm just going to start talking. Files, rasp, a little bit of sandpaper. You definitely want to ease those edges right there, and ease these edges right here, and clean up any out of squareness in these corners, because you'll get a false reading if there's a little bit of a bump or hump somewhere, and you'll think that you're still too long. But as long as you can remove that, then glue or epoxy will be able to squeeze out. Okay? So it's a handmade guitar, and that's about all it takes. It's just a lot of time and a lot of ingenuity, of course, and some quality tools. All right, guys, I appreciate you dropping in, and I'll see you in the next video.